Hi everybody, welcome to the Energy Management and Economics Lecture 3, Time Value of Money. So today I am going to cover the time value of money. What do you mean by the time value? Money should be the same value. $1 is $1, whatever may be the time. Is it going to be different? $1 is going to be different as the time moves. This is a very important question to be understood, and I'm going to explain the time value of money in this chapter. So let me start explaining the concept of time value of money, which is dependent upon depreciation, inflation, and present worth. Let me take a simple example of the story of an egg. 50 years back, an egg would have cost maybe 5 cents. And today, if you go to NTUC and buy, one egg may cost you 30 cents. So 5 cents to 30 cents in 50 years. An egg is an egg. The value of the egg is the same. But then what did change? $1 remains the same. But the 5 cents pegged to an egg 50 years back has become 30 cents pegged to one egg now. That means the value of money has depreciated. That means there is an inflation in the market. So putting it differently, given a choice between $100 today and $100 1 year from today, which one would you prefer? I'm sure $100 today, because if you get $100 today, you can deposit it in a bank and collect interest, and 1 year from now it will become more than $100. So that means the value of the money is associated with interest. Okay, if I had purchased some commodities using that $100, which will not perish, okay, such as gold or rare metal, and 1 year later, due to the inflation in the market, I can get back more money by selling that commodity. So there are two factors that attributes the value of money being depreciated, which is interest and inflation. So let's start with the first factor, which is interest. Interest is the ability to earn a return on money which is loaned rather than consumed. That means if you have got $100, putting into the bank, you can get more money out of that $100. But if you consume today by spending the money in a party, that money is gone. Okay. How about putting it in other things other than the bank? I use that to change the lamps in my house, with the old lamps replacing with the new LED lamps. Will I save money? That is the energy management aspect of money. That is why this subject is called energy management and economics. The next aspect is inflation. Inflation, in fact, is a very complex subject. Okay, it has also have got an impact on the demand and supply of commodities. In general, you can say inflation is the decrease in purchase power. Okay, for example, if you have got $100 and you go to the market and buy things in a basket, whatever you can buy today is more than what you can buy $100 1 year from now. That means 1 year later, if you go with $100 to the market, you could not have purchased all the things that you would have bought it today. So buy today. Okay, don't wait for the inflation to eat in. That is why Singaporeans run to the market hoarding things. It is not because of they are worried about tissue paper will go away. It is because the inflation will kick in and the value of tissue paper will go up. The value of those oil, rice, etc. will go up when the inflation kicks in. Okay, I hope you understand the economic aspect of hoarding. So now, as I said, that inflation is a complex factor. I keep that to make it simpler. Okay, let's look into the mathematics of economics. Okay, and we will look only the interest aspect. Okay, so today if you are having a value of p means present. Okay, present value of a commodity is known to you, and today you know the interest rate. Say for example, the bank interest rate is 0.25%, or if you have some FDs, it can give 2%, 5%. Singapore savings bond gives you 2.5%. CPF gives you 2.5%, and as part of it give you 4%. So there are places where you can earn interest a couple of percentage, single digit. Okay, and so if I put my money in such a scheme, okay, where there is an interest, as the years pass by, after n number of years, okay, n is the number of years, okay, the value of the money, your principal, which is p, will become the future value, which is f. Okay, and it will be a higher number, and the relationship can be stated as the future value is the present value plus the interest that you earn in. So this is the mathematical relationship between the future value and present value, considering only interest. We are not focusing on the inflation aspect of it. Okay, we are only focusing on the interest aspect of it at the moment. I hope it is clear to you. Now, when you talk about interest, there are two ways to calculate interest. Okay, if I get 4% interest for 5 years, okay, you just calculate, take the percentage, 4% of the principal, and that is your interest. Okay, that is called simple interest, and it is easy to calculate. Just multiply by the interest rate. Okay, but however, most of the banks, or in reality, it doesn't happen like that, because if you put $100, 1 year later it becomes, say, $110, assuming 10% interest, then your principal is now $110 for the second year. So the third year, it is based on the compounded value of 110 as the starting point, not as 100 as the starting point. So such calculation is called compound interest. Okay, so in other words, interest itself is classified into simple interest and compound interest. So simple interest is very easy to calculate. You take the principal and multiply that with the interest rate and you get the total interest for the period. Okay, you can refer to the table in the next page. Okay, table 2.1, the annual calculation of simple interest. So here the vertical direction is the number of years, and if you put P, the principal P in the present value, today I have 0th year, I have P. 1 year later, I will have P times the interest. That means P plus the interest rate multiplied on the principal. So the equation will become, taking P outside, P into 1 plus I. The second year later, okay, it becomes P plus 2I. The next year it becomes P plus 3I. So like that it goes over the period of years. Okay, I hope this simple equation is clear to you. We will debate it in much detail later. So here is a question that you need to answer now. If you have understood simple interest, determine the balance which will accumulate at the end of year 4. Okay, I put the money today, year 0, 1 year later, 2 year later, 3 year later, and 4 years later. How much will be the money? I start with $500 and I assume that the bank is going to give me 10% per annum. Okay, but it is not going to be cumulative. It is simple interest. So can you please calculate it now? I hope all of you got the answer correctly for this question. However, I'll go through the answer step by step. We have been given this equation, future value is equal to present value times 1 into n times I, where n is the number of years and I is the interest rate. So the n, which is the number of years, is given as 4 and the I, which is the interest rate, is given as 10%. Okay, so substituting these values in this equation, you will get, if you put $500 in the bank at the interest rate of 10% for a duration of 4 years, at the end of it you will get $700, $200 more. Oh, that's very good news. Okay, but only thing is that Singapore, you cannot find a bank which gives you 10% interest. Now let us look into compound interest. Compound means every year it is accumulated. That means you put $100 today, 1 year later you get $100 plus its interest. Then your principal becomes the bigger number. It is accumulated, and for the next year you get for the accumulated amount, not on the principal, and year after year it increases and increases. So it increases exponentially. That means to the power of n as the number of years goes by. Instead of direct multiple of I into n, it becomes I to the power of n. And this is illustrated in the table number 2.2. So look at this table. The vertical direction is the number of years. When you put in the principal on the 0th year, the principal value or the present value remains the same. 1 year later, it is just like simple interest. It is P times I. But second year, your starting principal is this new number, not the original principal. So your starting number is P into 1 plus I. Therefore, the end of the second year, it becomes I plus 1 squared. Okay, it goes to the top. And same, then the third year, the starting value is what you have completed the interest on the second year. Therefore, at the end of that year, it goes to P into 1 plus I to the power of 3. And that goes on and on and on. So we get a... Therefore, the generic equation for the compound interest can be written as P, the present value or the principal, times 1 plus I, where I is the interest, the whole to the power of n, where n is the number of years. So the future value after n number of years is equal to the present value times this factor, okay, which is 1 plus I to the power of n. I hope that is clear to you. So let me test you whether you understood the compound interest. Here is an example which you need to compute and tell me the answer. The question is for you to determine the balance which will accumulate at the end of 4 years. I use the same number of years as last time, and the bank interest of 10%, same as last time, for the same amount of principal, $500. Okay, we did the same question for simple interest. Now you are asked to do for compound interest. Try and let me know. I hope you got the solutions right. Let me go through the solution first. The first thing is that we start with the equation principal into 1 plus I to the power of n for the compound interest in order to calculate the future value after n years. And so we substitute the values. N is given, number of years is given as 4 years. The interest rate is given as 10%. 10% becomes 0.1 because 10 divided by 100. So the equation is the principal, which is 500, times 1 plus 0.1 to the power of 4, which is 732. Now let us compare it with what we got last time for simple interest. Last time we got the simple interest as $700. So now we are getting $732. The principal is the same, the number of years is the same, interest is the same. What is the computation? Instead of a flat rate of 4%, we say that after every year, whatever interest is gained, that becomes the principal for the next year. That means there is interest on interest. So the interest get multiplied and therefore you get $32 more as compared to simple interest. So for all practical purposes, banks gives you compound interest, not simple interest. So simple interest, whatever I have explained, is for the foundation. You can forget it now. Henceforth, I will be using only compound interest during the entire subject. And this is an equation that you need to remember. Okay. Oh my God, so difficult equation I have to remember. Don't worry, I have a simple solution for you to make it remember. Okay. Okay. Now what I'm going to do is to explain to you how to easily remember this equation. F is equal to P times 1 into 1 plus I to the power of n. Okay. This is called the single sum cash flow. Single sum because there is only one principal, just one number P, the current value. Okay, and you are computing one future value, just one number, based on the interest rate and the number of years. So let me put the whole thing into one box. 1 plus I to the power of n. So if I take the principal value, which you know what you are putting in bank today, multiply by a big equation which we call a number, a factor. Okay, we call this as a factor. 1 plus I to the power of n is called a factor, and the factor applicable to the compound interest. Okay, and we give a term for this factor. We call it the future worth factor for the single sum payment. Okay, so if I know the present value and I multiply by a number which is called the future worth factor, I will get the future value. Okay, so what are the things that I need to know? I should know what is the principal now. I should know what is the interest rate now. I should know what is the number of years now. So I put it in this fashion. Okay. Yes, I know what is the principal. Yes, I know what is the interest rate. Yes, I know what is the number of years. And put a line like this. This is called a pipe. Okay. These are the things. On the right side of the pipe is all the things I know. And the left side of the pipe is what I don't know. So just like the pipe is on your equation, okay, the left side is the future value to be computed. The right side is we start with the principal that you invest today, knowing the interest rate I, knowing the number of years. Okay, now let us dig into how to get this factor into one single number. If you know this number, I can avoid taking my calculator and calculating such a complex number. Okay, this is a shortcut that I'm going to teach you in order to do the economics effectively. Okay, before I start explanation on this slide, can you take a pause over here and open up your folders and find this appendix, which is called the time value of money factors. The name of the file will be TVM appendix. Okay, once you have opened the appendix, are you ready? Then let us look into the single sum cash flow equation. So our purpose is how to solve such a complex equation where there is a factor called future worth factor, and it is a big complex equation. Okay, so in this particular appendix, we have solved this equation and put it in this format: F pipe P comma I comma N, and this is for single sum cash flow. This is a summary of many other series. So you go to the single sum tabulation and look at the factors. We need to know I. So every page of this document is corresponding to the interest I. One page is 1I, 1%. Next page will be 2%. Next page will be 3%. Like that it goes. Okay. And the next factor that you need to know is the number of years. So the number of years increases in the vertical direction on each page. So the number of years is 1 year, 2 years, 3 years, 4 years, etc., etc., etc. goes down. Now, which equation to select is the next question. Okay. So here you categorize this one. The left side is what I don't know. The right side are the values that I know. It is in my hand at this point of time of computation. So use this particular format, okay, where there is a pipe, the left side of which is unknown and right side are the three knowns. So compare over here and you will find that this particular equation on the first left, okay, matches with this. So the value of the factor after 1 year, it will be 1.01. The value of the factor after 2 years will be 1.02. The value of the factor after 3 years will be 1.0303. Okay, assuming interest rate is 1%. You scan to the next page, you will find the same factors for I is equal to 2%. And the third page for I is equal to 3% and so on. Let's practice to make it perfect. So here is a quick preview of the single sum and the equation. Once again, every page is the interest rate. One interest rate, 1% is one page. Interest rate 2 is another page. Interest rate 3% is another page, etc. And each page, the number of years where the money is deposited in the bank, okay, is indicated by each row. So after 1 year, this is the factor. After 2 years, this is the factor. After 3 years, this is the factor, etc. Okay. Now I hope you understood the explanation, and I want to do the same question that we earlier did for compound interest. Okay, and the same values I put over here. You deposit $500 in the bank for a period of 4 years, and the bank is paying you 10% interest, and it is a compound interest. As I said, we are looking into compound interest only now. We are not interested in simple interest anymore, okay, because in reality it is always the compound interest that works. Okay, now I know the present value P, I know the interest rate I know the number of years N is equal to 4. So right now I know the value of P, I know the value of I know the number of years N, I don't know the value of future. Okay, so this is the equation to be digged into for the period. So for the period of 4 years. Can you please do the sum yourself and tell me the answer now? Okay, congratulations to those who got the answers correct. It is approximately $732. Okay, the same as what we have calculated earlier. Okay, let me go through the answers step by step. Okay, so if you had used the equation, you would have used the equation P F is equal to P times 1 plus I the whole to the power of N. Okay, because we wanted to reduce that equation to a simpler form, we use this time value money sheet. Okay, as I said, we have to use the single sum and we have to use this particular column of this table. Why? Because what we know at this point of time is I know the present value, I know the current interest rate, I know the number of years. Okay, so therefore, and I don't know the future value. So I use this particular equation in order to determine the future value. So this is your factor to be taken from the table. How do I do? You must start with the percentage interest rate. So the first thing that you have to do is page your this thing to the 10th page where I is 10. Okay, so once I is 10, then you go to the next factor, which is the number of years. In this case, the number of years is 4. So the number of years is n, which is growing in the vertical direction downward. Every row is a year. So year n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. So matching this particular column, matching this particular row, what you get is the factor is 1.4641. So you copy down that factor over here. Okay, so this is the factor to be multiplied by the known figure, which is your initial investment 500. So just that's not a final answer. The factor is not the final answer. Okay, please remember you have to take the factor and multiply by the principal. If principal is double, your output, the future value also will be higher, right? That makes sense. So for the given value of 500, for the given period of 4 years at a 10% interest rate, we compute 732.05, which is the one which we got earlier also using the equation, full equation for compound interest. I hope that is very clear to you. Let's proceed. Okay, now let me explain to you how to apply the compound interest formula to reverse calculate. That means I want to get $10,000 after 10 years. And I know that the interest is 10% in the bank. How much of money I should be putting today in order to get $10,000 10 years from now with 10% interest? So that means whatever we have been doing, I wanted to reverse do the calculation. So in other words, what if we want to know the P to be invested? I don't know what is the amount to be invested, but I know what exactly I would like to get after 10 years. I know how many years later. I know what is the current interest rate in the bank for the next 10 years. Okay, I must know for the entire period what is the interest rate. And how will you do? This is what I'm going to explain next. So for this, we use the same formula as we have learned, like future value is equal to present value into 1 plus I the whole to the power of n. Okay, the same equation. And if I don't know the value of P, then what you do is rewrite the equation with P on the left side. So bringing this particular factor 1 plus I the whole to the power of n to the left side, to this side, then I will be dividing the future value divided by 1 plus I to the power of n. Okay, please note that 1 divided by 2 to the power of minus 2 is the same as 2 to the power of 2. Okay, or 1 by something to the power of n is that something to the power of the negative n. So here it is negative n, this will be positive. If this is positive, then this will be negative. Okay, using this simple mathematical thing, I can rewrite this equation again over here. Once again, I can rewrite this equation over here again as the present value is equal to the future value, which I know how much I am going to get, and it is multiplied effect by a factor. Okay, so this is how I will be able to calculate future. I am going to get the yield of like this. Therefore, present, how much is the net present value? Net present value. This is very important equation, because when you are doing a simple electrical installation, say for example you are changing the lights today, okay, and you are going to save electricity, right? But you have not saved the electricity. Okay, if by changing the lights in your house, by spending $5,000, I'm going to save $50 every month for next 12 months, next 10 years. Okay, assume the life of the lamp is only 10 years. So you are going to get in future the returns. But I don't know that future return is worth or not. So it is very important to have the net present value to be computed. Okay, that is why this equation is a very important equation and will be used throughout your energy management and economics. Okay, but don't worry, if it is not clear, I will explain one more time in the coming slides and make it very clear. Okay, let's proceed to the next one. Hi. So far you have learned that we define a factor based on the entire equation, okay, which is 1 plus I the whole to the power of minus n in this particular case, and plus n in the first case. When you are calculating the future value based on the present value, it is plus n. And if you are calculating the present value based on the estimated future value, this is minus 1. Okay, whatever it may be, we have a single value of present value and we have a single sum of future value. So the whole thing is called a single sum calculation. Okay, and this factor which we had calculated is called present net factor or the single sum payment factor. Okay, or it is also called the present worth factor. So basically, if you know what is going to be your future estimated value, I want to get $10,000 in future after 10 years. I know my interest rate in the market. I know the current date to the maturity date, that is number of years. So these are the things on the pipe. This line is called the pipe. On the right side, whatever you write are the known things, and the unknown things is, in this case, is the present value. Okay, I don't know what is the present value. Okay, I want to get $10,000 after 10 years. I want to put some money. How much is that money that I want to put today? That is P. I don't know. I want to calculate based on future value f current interest rate for the next 10 years must be a constant interest rate I and the number of years, which is 10. Okay, so this aspect is the one which is to be extrapolated from the table. So by now you must be very familiar with how to read the table which is given to you for calculating the single sum present worth factor. Now we will go to a higher level after doing some exercises. So here is a picture of the table that I have given you in the Word format. Okay, I go through the components once again. Every page on the left corner is I, or the interest rate. So first page is for 1%, second page is for 2%, third page is for 3%, and so on. Okay, on each page the number of years n is progressing in the vertical direction. Each row in the table is the number of years: year 1, year 2, year 3, etc. Now we talk about only single sum. Single sum means I have one present value, and after number of years later I have one future value. Okay, so if I have known the present value now, I want to predict the future value, then I will be using the left hand side, the first column. Okay, but if I know the future value and I want to reverse calculate the present value, then I will use the second column. Okay, this column. Okay, so that's the difference. So I hope you understand the concept of single sum payments based on net present value, future value, and based on the future value I can calculate back the net present value. So you may ask the question, why single sum? Okay, today you put the money and 5 years later you get the money lump sum. But actually it is not like that in real life. Today if I'm making an investment of $5,000, putting it in my lighting system, that is my investment. That's also an investment, right? I invest in money in my lighting system, change all the lights in the house, and all the fans I change it into DC motor fan, which is highly efficient, and then all the aircon I change it into inverter technology, which is more efficient. Okay, with 5 ticks. Okay, so I am going to save energy, right? But this saving is not going to be lump sum. After 5 years you save something like that. The saving is going to be bleeding, like first month I save $20, second month I save $20. So in 1 year I save $2,400, $240, sorry, 20 into 12, $240, and 10 years I saved $2,400, and I have invested $1,000. So I have got more money. Okay, now that situation is called a uniform series. I put one lump sum today and I reap the rewards in a uniform every month basis or every year basis. Okay, the other way also possible. Every month I put into, like, your CPF contribution. Every month you contribute to your CPF, and then towards the end, on the retirement day, you are going to get a big lump sum, and that is also called uniform series. Okay, we are going to discuss this uniform series, which is more realistic in energy management and economics times. Okay, so whatever that we have studied, single sum is only a foundation to understand the concept. If your concept is ready, we are ready to move on to the more realistic calculation, which is based on uniform series. I hope it's clear to you. Let me proceed to the next slide. Okay, Now, I want to make sure that whatever I have been telling you until now, you have understood very well. Okay, to ensure that you have understood, please do this example. The question is, if I want in future $1,000 5 years later, okay, and you know that the current interest rate in the market is 8%, the bank is offering me that, and I want to put some money today. The net present value P, I don't know. The future value 1000, I know. The number of years, I know, 5 years. The future yield I would like to have, I know, $1,000. So can you please calculate for me what is the net present value or net principal that I have to place in the bank today? Take a moment, answer this question. I'll come back with the answer once you have done it. Okay, so let us look into the solution to the problem. Okay, and we know that from today, 5 years later, that means 5 years later, the n is equal to 5. I want $1,000 to be yielded. That future I want 1,000. Okay, I know that the current interest rate is 8% compound interest. Please note that we no more look into simple interest. We are interested only in compound interest. So this is your pipeline, and the three things that we know is on the right side. Okay, and now start with the interest. Okay, item number 1 is start with the interest. So interest is 8%, means you go to page number 8 of your reference table. The next one you look into is your number of years. So the next one is number of years is increasing vertically. Each row is 1 year. So year 1, year 2, year 3, year 4, year 5. Oh, so this is the one. Then we have to take by the entire formula. That means for compound interest, for the known future value, interest and number of years, the unknown P can be, net present value can be calculated, okay, using this formula. So the second column of the single sum is to be taken. So for the year of 5 years, okay, so you will end up with the cross section where the factor is 0.6806. So this factor is evaluated to be 0.6806. Please note that factor is not the answer. You have to multiply the factor with the value that you are supposed to deal with. Okay, I want 1000 future in the future, right? So that 1000 has to be multiplied by the factor 0.6806, and that will give you the answer 680. Okay, now just to be sure that your calculation is right, let us look the other way. Now I have $680.60, and I put in the bank for 5 years, and the bank is ready to give me 8% interest. Will I get $1,000? So in order to do that, what I know is present value, which is $680.60. Interest rate I know, number of years I know. So I will be going to this formula. Okay, and my principal is what? Today's value is $680.60, right? So I will be going for this formula, that is the first column of your single sum, and then take this number 1.4 69 and then multiply with the today's value, which is $680, you will get back the $1,000 in future. So the future value is going to be $1,000. So this is the reverse calculation of the question, okay, to ensure that the answer 680.6 is correct. I hope it's clear to you. Let's proceed with some more questions to be done by you.